Hello, everyone. So Professor Lee asked me to make a little video on Lab 8, so let's get to it. Professor Lee will post the full Lab 8 solutions to Beat courses, so if he hasn't already. So for this video, I'll just be showing some skeleton code in MATLAB for each part. Let's see, problem 1. So it's pretty straightforward. Given a matrix A, find its inverse if you can, or if you can't find a return an empty matrix. So for problem 2, there's a two-parter. You'll be coding two methods for finding the roots of a function. First, Newton's method, as shown here, and bisection method. So the difference is Newton's method's very fast, but it can be a bit unstable, versus the bisection method is, well, it's slower, but it's more stable. And if you're curious about the intricacies of how each method works, check the Lab 8 PDF. Problem 3 is a bit scary, but don't be intimidated. It involves using complex numbers and Newton's method to create what's called a NewtonFractal. If you're familiar with the Mandelbrot set, it's similar to that. So first thing, I'm just going to give you the entire solution here. It's to, given some number d, compute the exact solutions of a polynomial as given in the PDF. So second, use a function called NewtonConv to determine whether a function converges, and if so, what number it converges to. Third, now this is a little bit long, so I'll start at the top and then scroll down as I go through it. It's called NewtonFractal, and it basically uses the functions that we've seen earlier, NewtonConv, to plot a NewtonFractal, and there's images of that in the PDF. So this is the first part. Scroll down a little bit, and a little bit more. And I'll just give you this entire thing because it's not much pseudocoding, it's just a lot of plotting. Okay, so thanks for watching, and have a nice Halloween.